Welcome back, Math 152. Before we were talking about a quantitative variable and we wanted to determine something about the population, and in that case was the mean. What about if we have a qualitative variable? So then we're talking about proportions and how do we develop a confidence interval for proportions, and that's what we're going to talk about in this section, 7.3. So let's get started. So we're going to do confidence intervals for a population proportion, and here's what we're going to do. So let's take a look at an example. I've got a music organization like Little Kids Rock, and they surveyed 517 music teachers, and out of those, 403 of them said that video games like Guitar Hero and Rock Band, in which players try to play music in time with the video image, have a positive effect on music education. So this is a proportion, 403 out of the 517, and that's a sample, right? So this is a p-hat type situation. But what about if I wanted to know, if I wanted to take that and infer something about the population proportion? How do we do that? So assuming these teachers to be a random sample of U.S. music teachers, we would like to construct a confidence interval for the proportion of music teachers who believe that music video games have a positive effect on music classrooms. So here's some of the notation that we're going to work with in developing a population proportion confidence interval. P is the population proportion of individuals who are in a specified category. So you're either in the category or without. X is the number of individuals in the sample who are in the specified category, and N is the sample size. So out of the sample, this is what we are talking about. P hat is the sample proportions, and we calculate the sample proportion by X over the N. So that is the P hat, the sample proportion. Okay. So again, in confidence intervals, we're always interested in getting a point estimate. That's the center of our interval. And then we're going to have a standard error, and then we're going to multiply the standard error by a critical value to give us the margin of error, and then we're going to take that point estimate plus the margin of error, point estimate minus the margin of error, give us the confidence interval. So we're always doing that, but we just tweak the value of the standard error and what we use to do the critical values. So here our point estimate is p hat x over n. We need the standard error. The standard error of p hat is the square root of p hat 1 minus p hat over n, and we solve that for central limit theorem for proportions. And then we do the margin of error. Here we're going to use back to standard normal, the z alpha over 2. Okay? And then so we're just going to do margin of error, the critical value, times square root of p hat 1 minus p hat over n, and the p hats again are from the samples. So everything is based on the sample, and then we calculate and we do the confidence interval, point estimate plus or minus the margin of error, p hat plus or minus z alpha over 2, square root of p hat 1 minus p hat over n. I want to pull down. Sorry. So the method for constructing a confidence interval for a population proportion requires that the sampling distribution be approximately normal. We have a simple random sample. The population is at least 20 times as large as the sample. Here's an additional one, and we just need that large sample so that it's independent. The items in the population are divided into two categories. You're either in the category or not. You either like the music or not, you like this color or not, so it's a categorical qualitative variable, and you're either in that or you're not. So several things you may have, who likes red, yellow, blue, green, but you're only going to focus on either you like blue or you don't like it. So the sample must contain at least 10 individuals in each category. So you have to have p hat, n p hat has to be greater than or equal to 10, and n times 1 minus p hat, the other side, to be also the 10. So here it was. In a survey of 517 music teachers, 403 said that video games, guitar, hero, and rock band have a positive effect on music education. Construct the 95% confidence interval for the proportion of music teachers who believe that these video games have a positive effect. So let's check our assumptions. Simple random sample. The population of music teachers is certainly larger, that 20 times as large as what 517 is. So I can divide them into two categories. You either believe that the games have a positive effect or not. Okay, and here is the size of those. So 403 teachers believe that they have a positive effect. The others, 517 minus 403, 114, who do not. So both of them are at least 10. We had 517. The X that believed in it, that it had a positive effect, was 403. So our P hat, X divided by N, 403 over 517 is 0.779497. So that's our P hat, our sample proportion. So again, we're using back to the normal table for this one. And we will do 95% confidence. 95% confidence, I come down here and I say, okay, the critical value is going to be 1.96 to give us that. So the margin of error, Z alpha over 2, the 1.96, square root of P hat 1 minus P hat over N, the 0.779497. That was from calculation from the sample. 1 minus that value, 1 minus P hat, that should have been the 1 minus 0.77. Over 517, that gives you the 0.035738. Now that we have the margin of error, we're just going to do P hat plus or minus the margin of error, and that'll give us the population proportion. When we're doing population proportion, we need to have that number to be between 0 and 1. If you come up with something bigger than 1, less than 0, this is not going to be it. Okay. So, and here's how we communicate it. We say we are 95% confident that the proportion of music teachers who believe that the video games have a positive effect is between 0.744 and 0.815. So we can also do this with a TI-84. It has built-in tests that we can run. I'll go over these real quick. So this is the same problem. Everything's the same. All the assumptions, but I'm just going to go into stat, go into test, go all the way down, and I'm going to do the proportional Z interval. Proportional intervals, and using the Z for critical values. So everything will come down here and it'll say enter the values of X, N, the C level, and then to calculate. And it gives us this interval, so this is 0.74376 up to 0.81523, and they rounded up here to 0.744 to 0.815. So we're 95% confident that the proportion of music teachers who believe that the video games has a positive effect is between 0.744 and 0.815. Between 74.4% and 81.5% is what it's saying. So in this, we're also going to do a sample size to obtain that confidence interval of a given width, a given margin of error at that confidence. So this is the same thing here. If we wish to make the margin of error of a confidence interval smaller while keeping the confidence level the same, we can do this by making the sample size larger. It always helps. We can narrow down on the value of the parameter by taking larger sample sizes. So if I solve, basically the N is what I'm solving for. So I'm M over the Z alpha over 2, square that to get rid of the square root, and then N here and P1 minus P hat, or P hat 1 minus P hat. This is the the formula for finding the value of n for a given confidence level and a given margin of error. But now, here is something we need to work with. We're saying I want a sample size, but I want to get, but I'm using p hat and 1 minus p hat. P hat depends on the sample. We've already gone out and got a sample, is what it's saying. So in case this is two situations that we're going to work with, and it seems to work pretty good, is that if we've never taken a sample before, we don't know what p hat, 1 minus p hat is, I'm going to assume 0.5. So 0.5, 1 minus 0.5, this makes this the biggest that it gets, this number here, and then I just fill in with those. If I've had some previous sample information, I'm going to use a previous p hat value. So I'll use one of those two situations. Okay? And again, once I calculate n, I always round up. So here's their statement. We can set the value of m, z alpha over 2, but we don't know ahead of time what p hat is going to be. So I'm either going to use a value that is available from a previously drawn sample, or assume p hat is 0.5 to get us started, and then we can go from there, take a sample of that, and then that'll get us some information for the future. Okay. So here's in a survey of 517 music teachers, 403 said the video games Guitar Hero and Rock Band have a positive effect on music education. Estimate the sample size needed so that I have a 95% confidence interval, and that will have a margin of error of 0.03. So now we have some, based on this 403 over 517 is our p hat, so we have some previous information. So I get everything to z alpha over 2 at 95% confidence. I still do the 1.96. The 0.03 is our margin of error. There's our m. But here the 0.779 is from the 403 out of the 517. So I have that information. I use that to get a sample size rounded up to 734. Okay. So now we want to do a 95% confidence teacher. We plan to sample music teachers to construct a 95% confidence interval for the proportion who believe that listening to hip-hop music has a positive effect on music education. We have no idea of p hat in this case, but we want to estimate what sample size we would need to get a 95% confidence interval with a margin of error of 0.03. Here we don't have any previous information. We do the 95% z alpha over 2, margin error of 0.03, but I'm going to use the p hat as 0.5. Okay. So again, the 1.96. The m is 0.03. The 0.5, 1 minus 0.5, so it's 0.5 times 0.5 is 0.25, and that gives us 1,067.1, and I'm going to round up to 1,068. Okay. So here's a little tweak, so it's not much on this one. We're going to have maybe two small samples that it wouldn't work for the previous one. We didn't have NP, or n times 1 minus p hat, to give us bigger than or equal to 10 on each one of those sides. If this is the best I can do with small samples, there's just nothing else I can do. I can do a confidence interval, but I have to kind of tweak what I've just did. So what I'm going to do is say for a small, where we needed to have at least 10 individuals in each case, but I don't, I'm going to bump whatever that x over n is by 2 in each case. So if I started out with a x of 4, I would move that to 6. The n was 10, I would move that to 14, because I'm assuming both the 2 in the category and the 2 outside the category. So the whole sample size increases by 4. Okay, so instead of using the sample proportion p hat over x over n, I'm going to do x plus 2, n plus 4. That gives us an adjusted sample proportion. And notice, I'm no longer using p hat. Here's the p hat here. This is p tilde. And that gives us p tilde x plus 2 over n plus 4. And then everything else is going to be the same. Standard error becomes p tilde 1 minus p tilde over n plus 4 to give us our standard of error. So it's just the formula tweaks a little bit. Here I only have a random sample of 10 businesses in a certain city. 6 of them had more than 15 employees. Use the small sample method to construct a 95% confidence interval for the proportion of businesses in the city that have more than 15 employees. So 6 of them had more than 14. So it's 6 over 10 would be our p hat. The NP, which is the 10, I've got the 10, but the other side I've only got 4 of those. So I'm sorry, 6 in the category, 4 outside the category. So neither one of those makes the NP greater than or equal to 10. So I've got to use the small sample method. So here's my adjusted sample proportion, p tilde, x plus 2 over n plus 4, 6 plus 2, but I'm going to assume along with the category 2 that it spread out that additional 2 and the not more than 15. So here's our n plus 4. That gives us a p tilde of 0.5714 that I'm going to use. Everything else is basically the same. P tilde plus or minus is the critical value. P tilde times 1 minus p tilde. N plus 4 is our new sample size, is what we consider. Okay. So when we do our calculation, z alpha over 2 for our 95 was the 1.96. So we get 0.312 is less than p is less than 0.831. So we can say with 95% confidence using the small sample method that 31%, between 31% and 83% is the population proportion. Notice that this is a pretty wide proportion interval. Okay. So let's stop at this point. We will work on these naturally in lab, and we'll continue next time. So have a good day.